Good morning, guys. It's Vince. I wanted to cover a video that I think I've never seen online, and I'm trying to think of ideas that will give you guys a little more knowledge before you start dropping in the hundreds, if not thousands of dollars on your CNC router to make you thoroughly understand what you're getting involved with. And a lot of questions I get asked is on G540. I get a lot of guys that'll buy kits. They think they're going to save money. And you will save some money if you decide to assemble it yourself. However, don't forget the fact that there is some knowledge required to do it properly and assemble the kit to give you the best performance. So what I'm going to do right now is do something I've never seen done. I'm going to go over basically a physical G540 in two videos. This video is going to cover the manual, which 98% of my clients read only after I direct them. I know that sounds kind of silly, but I'm trying to make you guys start realizing how important it is to really do your research. It seems to be forgotten today, and what I want to do is just break it down. It seems videos really attract more people's attention. So with that being said, I'm just going to dive right in. And this right now is the G540 manual. It's for the revision 8 model, which has been out now for some time. It is available on geckodrive.com. But there are some questions that come up with this manual routinely, and I'm going to cover it really thoroughly so you guys understand in the essence of this drive system and what you're actually purchasing. Okay, so that being said, you can see this is the revision 8 manual right here. One of the things that a lot of guys don't know or don't pay attention to is the G540 on the front of it has the step and direction signals for each axis. So that being said, if you think about it, you have basically all required information to go into your motion control software, be it Mach 3 or UCCNC software, and input the step and direction signals manually. The XML file that's available on Gecko Drive's site will allow you to put these settings into Mach 3 automatically by downloading that file and copying and pasting it into the Mach 3 folder for your default installation. That being said, again, I still like to know manually what my step and direction signals are as far as for each axis, and this is the quickest way. For X, it's 2 and 3, step is 2, direction is 3. For Y, step is pin 4, direction pin 5. For Z, step is pin 6, direction pin 7, and for A, step is pin 8, direction is pin 9. So guys, you've got everything right there to basically dictate motion. The next thing I want to cover is on the front of the drive. If you look correctly, you can see there's a wiring diagram even implemented on the front of the drive. It's showing you 6, 7, 8, 9. Those symbolize the DB9 pins that are connected or should be connected for your stepper motors. Okay, you can see there's B and then there's A. And again, I hope you download this manual so you could follow through this with the video to really get an inquisitive look as far as how they've done this, because it's really ingenious what they did. It's a question of people looking at the details, and once again, that's why I'm pointing them out to you. You can also see the resistor symbol, and you can see pin 1 and pin 5 symbolizes the resistor. So again, I'm going to cover the resistor later, but I wanted to just go over basically everything you're seeing with this manual. Okay, you'll also notice you'll have the schematic of what's the drive's dimensions. So you have the CAD schematic of the drawing of what the drive's actual dimensions are. So if you're going to mount it into a chassis other than my own, you know the actual dimensions for the G540. So now that being said, I'll scroll down. Now you're getting the physical and electrical ratings. Now a lot of guys don't even look at this. They go right to the 48 volts or 50 volts. Again, the Gecko can actually work with 18 to 50 volts. So the question here is, what's optimal for your system? Once again, it depends. I'll be honest with you. If you're looking for maximum speed, of course, the higher the voltage, the more speed you're going to get. But that doesn't necessarily mean that you have to go that fast. Most machining, anything you do with machining is always going to be slow and controlled because accuracy counts. If that wasn't the case, you could always do manual tools and it wouldn't matter. So really the question here is, what do you need your rapid movements to be? If your table is large or larger, or you plan on upgrading a table later on, you definitely want higher voltage, because that'll make your rapid movements much quicker. If table size is not an issue, you can always go with a smaller power supply. So That being said, really look at your budget, look at what you're planning on doing. You can always upgrade later, but does it always pay to upgrade? That's something you have to think about too, because if you're buying it again and then you're buying it once and then buying it again, so most of the time it's not as cheap as just buying the one and being 48 volts and being done with it. Okay? The next thing that I want to cover with you, and this is really, really critical, is the motor current. And if you look at the motor current, it says 3.5 amps, and this is where it gets confusing. A lot of guys read this. The one thing about Gecko I'm not happy with, there's only one thing I'm really not too happy with them on, is I think this is confusing to most end users. 3.5 amps is not what the Gecko puts out all the time, okay? It is the maximum amp rating of the drive. You are not getting 3.5 amps in consistent use. It is not a true RMS output of 3.5 amps. Now, I have proof of this because I went on to CNC Zone forum, and I was the only one that I've ever seen that posted the truth. And I'm going to prove to you now that I'm correct. And also Maris commented on what I posted, and you guys are more than welcome to read it. But once again, I cannot emphasize this enough. You are not getting 3.5 amps of current all the time through your motors. That is not the case. You are getting the true RMS rating, which is 2.47 amps of current through the motors at all time. Why is that? Because that's the square root. It's 70.7%, I believe, which is square root, and that will give you the true RMS setting. True RMS, guys, is very simple. That's the actual current rating in real world, okay, real world use. Something you really want to look at. And again, it really dictates a lot. It dictates the heat. It dictates what motors can be used. 3.5 amps, again, most guys just go with 3.5 amps. My motors are all rated to 3.5 amps as a maximum. Does that mean that they will not run with less amps? Of course not. Any motor will run with less amps. Again, the question here is, or I should say the explanation here is, what are we dealing with the G540? And now I'm going to show you, and I'll do the actual search with you, or actually I've got it right here. This is on CNC Zone. If you do a Google search for Gecko G540 RMS ratings, you can see where I actually broke down and I explain it. And this is probably the easiest explanation you will ever come to realize. Inside the G540, there's a 7 amp internal fuse that protects the driver. Okay? If this system was putting out 3.5 amps all the time, you would require a 14 amp fuse. And I pointed this out to Maris over at a Gecko Drive. Actually, I pointed out on CNC Zone, and because I kept getting questions of, you know, what motors and how many amps. Bottom line is this, guys: you're not putting 14 amps of current through a 7 amp fuse. So if the drive was actually capable of taking in 14 amps, how could you protect it with a 7 amp fuse, right? Common sense. So once again, we broke it down and we were talking, and finally, after we talked, he broke down the explanation. Now, he says his reasoning is a little different than mine, which it probably is. I mean, again, they designed this driver, so, you know, what he's talking about with the PWM duty cycle is around 60%. This is all scientific. I really don't care to get into the science of it. I really want to keep it as basic and as simple as possible. I think that's where it gets convoluted. But the interesting thing, and again, you're more than welcome to read this article on CNC Zone, and all you would have to do is, once again, Google Gecko G540 RMS ratings, and you can see this. You can see here that at the bottom, his response was, you can also look at it intuitively. 3.5 amps at 48 volt DC is 168 watts per motor, and it's enough heat to catch the motor on fire. Since that doesn't happen, then something else is going on, which, again, he's breaking down the science of the PWM duty cycles around 60%, and then it puts amps back into the power supply. Again, I'm not breaking down theory, I'm not breaking down science, I'm breaking down reality. And the reality is these drives, these G540 steppers, they actually put out 2.47 amps roughly in true RMS rating. They will put out the maximum 3.5 amp. I have yet to see that actually happen. And if you read right here on what he's, a matter of fact, he even states it right here, the average current drawn from the power supply is 0.7 amps for a motor that has 3.5 amps circulating in its windings. So again, you can see basically what you're looking at what that would be. Very, very minuscule. Even at the highest rating, I have seen it go to 2.2, 2.3, and this is actual measuring with a true RMS voltmeter. So everybody understands now what they're dealing with. Okay? Now everybody should know, and again, can do the research. This is reality. I deal with this stepper or the stepper system on a daily basis, and I can tell you this is real. So you guys all know now and are on the same page and have been corrected as far as what's going on with the G540. Okay? And again, this is not to say that the drive is misleading. I don't think it is. Most stepper systems that are out, they rate the systems on maximum amp rating. They do not actually rate them on RMS settings. I believe Leadshine does. Leadshine is one of the systems, one of the drivers manufacturers that actually do that. However, Gecko really doesn't. They're not really too detailed with it, and I like to be detailed with it because it gives you guys an idea of what you're actually dealing with on all spectrums. Does it matter? It really doesn't, but it's good information to know. As you build your system, you'll always know what kind of power you require for any extra motors and extra accessories. So it's definitely information that could help you. So that being said, we're going to go back to the manual. Now you guys understand the actual amp draw of the G540. The next thing we're going to do is we're going to come down here, and you can see all the physical and electrical ratings of the drive through the manual. Everything is broken down. You've got a maximum of 200 kilohertz input frequency. Again, the drive is super fast. The G250 ones that are in the system are really, really amazing. I don't have to tell you that. The history for them is long, and honestly, the G540 has quite a following. So I'm going to just scroll down past that. Now, this is a question I usually get, and I get asked usually by guys, once again, that are building their own system, is what resistor should I use? What size resistor should I use? And the easiest way to go through that is, again, if you read here, and it says, please read first before using the G540. Before installing, be sure to have a suitable stepper motor, a DC power supply suitable for the motor, and a current set resistor. The motor's rated phase current must be between 0 and 3.5 amps. Using a motor with a higher current rating will cause a proportional loss in torque, meaning a 5 amp motor will get 3.5 amps divided by 5, which is 70% of its maximum torque. Now guys, I don't know if you understand what that means. This is very powerful, and this is what a lot of people miss. Okay, let me explain this clearly to you. Okay, I sell 600 ounce steppers, and I sell 300 ounce steppers in my store. Okay, basically, you can, if your machine can handle 300 ounce, it can certainly handle 600 ounce. Does it make sense to do that? Well, it depends. Are you ever planning on upgrading to a larger machine? If you are, then it's not a bad idea. Once again, the 600 ounce would be a better investment. If you're not, then of course 300 ounce would be a better investment. However, there are some individuals who are looking at using larger type machines, more like the Grizzly type machines. If you really pay attention to what I just read there, okay, the G540 can power virtually any motor. Okay, so if you're looking at a stepper motor that's like this, just pointed out as an example, that's 5 amp rating. A 5 amp stepper usually will put out anywhere between, maybe I've seen them go up to 1600 ounce at 5 amp. So if you did the math there and you broke it down, you're still going to get quite a bit of torque even with only 3.5 amps. Now that being said, that's very powerful information that could really save you money. If you're really paying attention and understanding what you're reading, you can use a larger stepper motor that's putting out more ounce per inches based on an amp rating than you need, and then just do the math to where if it breaks down to 70% and it's usable for your machine and acceptable, you could do that and save money. Now, how is that done? Well, it's very simple. If you find a 5 amp stepper that's putting out 1600 ounces, okay, and we bring up my calculator. Hold on one second. If we go to 1600 ounce stepper, okay, and we minus 70%, I'm just doing it based on a 5 amp rating. Let's see here. Whoop. you're still at 1120 ounces. So even at 3.5 amps, you would still be getting 1120 ounce-inches of torque out of a motor that's based on 5 amps with the G540. What does that mean? Well, let's see. A Grizzly machine can easily run with a 900 ounce stepper. So you're well above that 900 ounce minimum rating, and on top of that, you'll most likely save you money. So what I just taught you right there, if you do the math, you take the time, you thoroughly understand what you're purchasing, this video will save you money if you're looking at a larger base machine. I get a lot of guys that question me on, will a Gecko handle this size machine? Let me clue you in on one thing. And now that we've got the math all broken down, one of the biggest things that I want to clue you in on is the fact that the Gecko can really run virtually any size machine. The question here is, what kind of rapid are you looking at? The larger the table, the faster you want the rapid so that the job will get completed in a reasonable amount of time. If your table is small, however, smaller, I would say 4 foot, 5 foot, you're pretty much good in that range. 48 volts is plenty. The reason to go to Gecko's Pro drives, where it's more like the G201s or the individual stepper drivers that can accept up to 80 volts, is due to the fact that your table is large enough to where it requires an actual rapid movement that would encompass that. So if you had a table that is actually, 8 feet, 9 feet, you want them rapids to be really quick so you're actually getting across the table in a reasonable amount of time. That, again, makes your job faster. However, to use one of those drivers on a table that's 3 foot, you're not going to see the maximum effect of them. So common sense prevails. More voltage, more speed. When is more speed necessary? That's really depending on the end user. So what I just taught you in this one part of this paragraph right here, and where it says, please read first before using the G540, what I just taught you there, if you're a guy using a larger system, I will save you money. That will definitely save you money. The next thing is, the power supply voltage must be determined by the inductance equation listed later, or be between 4 times 20 times the rated voltage. Again, we're breaking down science. The current set resistor may be a quarter watt 5% apart. Finally, have a step and direction pulse source available. Okay, what does all that mean? Well, basically, it's getting into the science of the inductance. Again, inductance is basic way to look at inductance is resistance. The lower the inductance, the faster the motor is going to basically move. But it's a trade-off. Again, there's lots of science behind this online. If you want to read the science, I got to be honest with you, a lot of it is crap. It's not necessary. Movement is movement. The speed of the movement, I've used everything from the 20 millihenry inductance all the way down to 2.8, 2.4. My steppers are very, very low inductance. I do that purposely. But is it a requirement? Yes and no. Some guys see a difference, some guys don't. I would say overall it's not something that's going to really hinder you, but the best thing is lower inductance is really better in the sense that it will be a faster motor for what you're looking for with the G540. So it's something to definitely look at. It's just to break down the science behind it, a lot of it's theory. And again, when you're sitting at the table, that theory goes out the window because now you're seeing movement. So just keep that in mind. Okay. Now as far as the resistor rating, okay. Right now, you already know if the resistor, I'm going to see right here because there is a part in here that discusses breaking down the resistor rating. I just want to make sure I didn't overlook it. Just give me 1 second. I don't believe I did. I believe this is really where you're looking at it. Okay, so overall, picking a resistor, okay, if you have a 2.8 amp stepper, you want a 2.8 K or ohm resistor, quarter watt 5% apart would be perfect. If you can't find that, get to the closest one you can find underneath that rating. So if you found a 2.4 K ohm resistor, you'd still be okay. The reason we want to use a resistor is because the G540, when the resistor is hooked up, whether it be through a DB9 or my solderless connectors, okay, whether you manually do it through the DB9 or the solderless connector, you are going to reduce the current going to your steppers, which means they generate less heat when the system is at idle. Okay, and that's a huge, huge thing when you think about it, because why would you want to generate more heat? Steppers already get very hot. There's really no reason to keep them that way. Here we go. Here's the actual part of the resistor to do the math to break it down. This is in the manual itself. Step 4 connect motors. Wire your motors to the included DB9 solder cup and secure the back shell connectors. If your motors are rated below 3.5 amps, you must use a current set resistor across pin 1 and pin 5. The resistor is calculated by taking the current in amps, and I'll just scroll down, and multiplying by 1,000. If your motor is rated at 2.8 amps per phase, you will have to use a 2.8K 5% quarter watt resistor. Well, that's pretty simple, guys. If you have a 3.5, you want 3.5K 5% quarter watt. Again, very simple. If you can't find the exact thing, you can always order it and get the exact thing. For the guys that don't want to go through all that, you can always use a smaller resistor. Again, the smaller the resistor, the less amps going through the motor. However, most of the time you're not going to see a huge difference. So if you get it close enough, you're going to be fine. In real world, you'll be fine. And again, the motors will run cooler. That's another thing to consider, guys. If you don't need all them amps going through the motors, they're going to run cooler. So you can use a smaller resistor if you choose to regulate the current. It's not going to hurt anything. As long as it's okay with your table as far as your table performing, you're just going to run your motors cooler, which is a good thing in itself. So that's something to think about, okay? Again, take your time. Think about this. For the guys that, again, they say, Gecko states that if you're having a 3.5 amp motor and you're using it and you're going to install it, you don't need a resistor. That's true. But why would you not want the system to run as cool as possible? Again, I don't know. Most shop environments, the heat is not on the low side to begin with. So again, the resistor is beneficial. You really need to look at that. I think anybody that's spending the money on a system of this caliber, you should definitely take the time and invest in the resistors. Guys, they're like 30 cents a piece. I mean, it's silly. So think about that and we'll keep moving on. Now you understand the resistors, you understand how to pick out your resistors. Again, this is all in the user's manual. You can download this once again from geccodrive.com, and it's under the G540's product description. The next thing is, it's going to tell you to connect the DB25. Again, for you guys doing DB25, which I'm not a big fan of the DB25 connection, but it's a very basic way to go. If you have holding torque, it states here in a green LED, you can plug in your DB25 straight through cable to the G540 in your computer. One thing here that needs to be pointed out, if you're going to use a DB25, it needs to be a straight through cable, meaning everything is wired in conjunction with the other end. If it's changed or manipulated, or there's other data things going on that they may have manipulated with the cable, you will have issues. Make sure if you're purchasing a DB25, which again, anything from my store is made for the Gecko, so you don't have to worry. If, however, you're purchasing elsewhere, make sure you're getting a DB25 straight through cable. Once again, use the pinout on page 7 to set up the program's output pins, or load the Gecko, or load the G540 XML configuration file from the G540 product page on the Gecko Drive website. That again will let you go through and set that up to where all your step and direction signals will be input into Mach 3 correctly. The XML file from Gecko is not required in UCC&C software. So once again, if you're loading Mach 3, the G540 XML that can be downloaded from Gecko Drive's website for the G540 should be downloaded prior to installing a DB25 and inputted into Mach 3's default location in order to get the G540 step and direction signals uploaded into the software the fastest way. It's just a quick way of doing that, guys. Again, your step pulse width must be at least 2 US wide, and the pulse polarity for the step and direct signals are active high. Again, that's, you'll go in and do that. I've never really messed with much of that stuff. You'll be pretty much set. The big thing with the DB25 when it's plugged in is you want to make sure that EPP is set on your DB25 if you're going that route in your BIOS of your computer you're using. Pay attention to that. It'll bite you. If it's set up, in a different format, you may have problems with actually picking up the DB25, and you may have motion problems. So just, again, go into your BIOS, check that. Again, this is all stuff that's regurgitated from Gecko Drive. You can find out if you do any searching on both websites, they're going to tell you about it. That's a very common flaw. Most guys that are getting involved with this at least know that. If you don't, again, EPP is the setting you want for your DB25 on your parallel port. So your parallel port setting in the BIOS, once again, needs to be set to that. Step 7, adjustment trim pot. All of the internal drives come with a tiny little knob on the front of the G540. I'll show it to you. We'll just scroll back up. This little knob here where it says trim, you just insert a flat screwdriver, preferably a nylon one. If you don't have that, be very careful because, again, you're inserting a metal unit inside the electronics. I'm careful with it anyways. That's just my feeling on it. And again, you're just going to go in there and you're basically setting it for noise. You're really not looking, and again, even here it states the trim pot is 270 degrees in motion and will have an audible sweet spot when it's in the proper position. If your motors sound kind of whiny, then more or less you're still looking for the sweet spot. You want it to be the least amount of noise generated, and you'll really look for that just by listening to them. It's not a science, guys. Don't ask me 100 questions on how to set it. It's just finding that sweet spot. It's not that big of deal if your motors are a little louder. It's the idea. You're just adjusting basically the current slightly. So that's really all you're doing. It's not, again, it's not rocket science. Play with it. It's a troubleshooting It's a troubleshooting thing where you're going in and at the end of setup on your system, you can go in there and manipulate that setting if you'd like. Some guys do, some guys don't. It's absolutely not a definitive feature in the sense that you'd be doing it all the time. Okay, once it's set, it's left. And honestly, on a new setup, that's where you'd probably be looking at that. Other than that, you wouldn't even worry about it. The next thing is your optional connections. Now, a lot of you ask a lot of questions about what can G540 operate with, and can I hook up a VFD, can I do all this? Now, my first and foremost, I'm going to tell you, the G540 does have input, outputs, and it has an analog output, which again, of course, is regurgitated in the manual. The thing is this: if you're a novice, you want to keep your setup as simple as possible, at least until you become familiar with what you've purchased. Now, that being said, I get guys that want to build rocket ships, and when I say that, I'm saying it humorously because, to buy a router and think you're building a Haas mill is foolish. Okay, you're not building a Haas mill, you're owning a router. If you're purchasing this machine thinking, or better yet, I shouldn't say thinking, I'd say determined, because I get a lot of guys that are determined to make it into more of a full-scale, they want to make it as realistic as possible in the sense that it's turning their coolant on, it's doing this, it's doing that, it's turning vacuums on. Look, you're more than welcome to do that, and you know what? Honestly, you can probably attain most of those goals. Okay, you can have the Gecko do it. The question is, if something goes wrong with this setup, are you going to be able to determine what the cause is? Now, that being said, that's where I lose most of the guys because they don't think that far ahead. Okay? Just because you can hook this stuff up doesn't mean you can troubleshoot it when and if something happens. Because I promise you, and I've said this in numerous times in my videos, there are always going to be times you're going to troubleshoot something. Always. Plan on it. If you're the type of person that doesn't mind sitting over the machine and troubleshooting it for hours, possibly hours, I should say, depending upon what your knowledge is, then I'd say do it. If you're the type of person that has a product in mind, is already looking at machining, and okay with, just getting the job done, I really want to get it done, I want to get done precise, I want to get done right, I want to get it, set up to where repeatability is there, this is not usually the guy I'm talking to, okay? The guy I'm talking to is the guy that's building his own setup, he feels he's electronically capable to do that, and he's doing it, and then he has later goals of adding, like I said, spindle controls, coolant controls, vacuum controls, different relays. Once again, and I cannot emphasize this enough, if you decide to wire this system up to have all these extra devices and something is not working with the system, you will find out very quickly how tedious and painful it is to try to diagnose it, because now you're not just diagnosing a G540, you have to diagnose everything attached to it, unless you're lucky enough to isolate the problem right away. Now the question is, how many of you are actually able to do that? That's the question. And I have to be honest with you, I myself don't like doing it, and I deal with it on a daily basis because there are so many variables. Again, I'm being honest. Think about that. Think about it wholeheartedly what I'm saying, because I'm telling you right now, it will save you time and frustration, and that usually equivalates to money in one way or another. So that being said, it's a lot, but to cover it thoroughly, I'm going to tell you, the G540 has 4 general purpose inputs called 1, 2, 3, 4. On the main terminal block, they are position 1, 2, 3, and 4. Typically, if you're doing home switches, that's where your inputs are going to go. Okay, on your home switches, that would be where you're basically going to go. Limit switches, once again, limit switches are not required. Technically, home switches are not required. You have your DROs. You can manually set it up to find a home position. You can actually go and read the DROs and do that. Again, a lot of guys, they're reading all this stuff online. They're seeing other guys with limit switches. A mechanical switch will never protect your table to the degree the software will. If it's set properly, the software is the best overall way to protect your table. And I've said this in other videos, and professional machinists that are using Mach 3 and pro-grade machines already understand this, but a lot of guys, they are adamant about putting these on their system. Do the math. Think about what I'm saying to you. Remember, if the software goes down, guys, the system stops moving. A switch is not going to do that. If a switch fails, you're screwed. And I'm putting it that way. You will have a crash. So think about it like that. Take it from a guy who's doing this. I'm telling you right now, research to see if I'm wrong. I mean, Haas Machine on YouTube, very interesting. His videos are really, really good. Probably some of the most informative. And again, he's a guy that is a machinist. He is doing this full time in the sense that he does a lot of machining. I'm telling you right now, the guys that know, they go that route. They can use home switches if they choose to, but it's absolutely not a requirement. Again, it's how well you know the software you're using. The better you become with the software you're using, you're going to find there's a lot of different things you can do that are redundant. And that's something to pay attention to. If you use Microsoft Excel or Outlook or any other of the Microsoft programs, you find that a lot of different functions are redundant. Well, you're going to find that as well. With Mach 3, you'll find it with UCC. There's a lot of different things of learning that you can do and pick up on. And again, it might save you, it usually will save you time, and it'll definitely save you money. So think about what I'm saying. Again, it makes sense. Outputs, G540 has 2 general purpose outputs called output 1 and 2. Again, the outputs are rated at 1 amp and 50 volts. Connect one end of the load to the output and connect the other end to load to the positive DC. The voltage may be the G540 power supply, or it may be a separate. Again, those are really used if you wanted to, connect something. I don't really connect anything excessive like that. If you're looking at position 5 and position 6 on the terminal block, those are really to drive your relay coils or for any other purpose. So again, if you want to make a rocket ship and you're looking at connecting and hooking up vacuums and stuff like that, then that would be a way to do it. But again, at what cost? Remember, simplicity saves you money. And I always use that term because it's a fact. Simplicity will always save you money. If you think in terms of time, your time and what it's worth will eventually equate to money, especially as you use this machine more. So think about what I'm telling you. I'm telling you I don't care if it's a full-scale shop. I don't care if it's a smaller grade machine. If it's scaled down, it's the same principle. Your money and your time, they're one and the same. So if you're okay with investing your time, then you're obviously okay with investing the money, because believe me, eventually there may be something that will require servicing, and then you'll find out where it's going to bite you. So just be careful. The next thing, analog output. You got a 0 volt to 10 volt opto-isolated analog output intended for use with VFD drives. That's the one to control your VFD. Okay, every VFD is different. Once again, I'm not a big fan of it. I would rather do it manually because, again, what are we talking about here, guys? You're talking about going up and either, adjusting the frequency on your VFD or just turning the knob on your VFD as compared to, having the software do it. Now, here's the big thing too, guys, and I gotta stress this enough. The software does not auto-calibrate to where it's going to keep your drive, or I should say the VFD, calibrated to an RPM. Okay, so more or less what you're getting is an output RPM. If your feed rate is too high, you may drop RPM. The software is not going to dictate that. So your best bet, again, depending upon who I'm talking to. If I have the guy that feels totally compatible with, messing around with VFDs and setting them up and playing with them, then he's going to be okay with hooking it up to the Gecko just to see the software control it. If he gets it right. If he doesn't, he's in for a lot of frustration, because I've seen that happen too. Because VFDs, a lot of them are different. A lot of the Chinese VFDs, which really there's nothing wrong with. I use a Chinese VFD myself, and I can tell you right now, actually I use a couple of them. I can tell you right now, if you set it up okay, you're all right for the most part. But again, if you run into an issue, you're going to burn yourself, because you'll be sitting there troubleshooting that as well. If you look at just the individual areas that we just covered, inputs, outputs, and analog output, those three scenarios are all potential problems. I want you to look at your system in that configuration, because if you look at them as potential problems, it's easier to eliminate them from the beginning and take it with the seriousness of, well, really, do I want to get involved with that? That's the question I want you to ask yourself. If you do and you feel competent enough, I say do it. If you don't, and you're a kind of guy like I am, where it's like, I like simple because I know simple makes me money. If I can make more money by being simple and doing it efficiently, that makes more sense. But again, I come from a different background. Some guys think, they want to tinker with things. They don't mind tinkering with things. They've got time. They want to, dissect things down to the nut and bolt. Do it. If that's what you want to do it. But again, each topic that we just went over, potential problems. Keep that in mind. Now we're moving down. Charge pump. Okay, G540 is equipped with a charge pump watchdog timer that disables the drive without a 10 kilohertz signal to pin 16 to the DB25. You can enable this by reversing what was done in step 3 and making sure that your parallel port is set to EPP mode. To do this, go into the BIOS. Again, I covered this already. Do this, go into the BIOS, set your parallel port, either EPP or send and receive. Most parallel cards are set to ECP or send only by default. Guys, pay attention to this, because it will bite you. Not the charge pump, but the EPP setting for your DB25. You want to make sure the parallel port, once again, in your BIOS is set to EPP or send or receive. I've never seen send or receive. I've just seen the setting EPP. So again, Gecko may know something I don't. In all the years I've worked with computers, I've never seen that. So either way, now you know what that is. Charge pump, guys, watchdog timer. I don't even use it. I've never used it. I don't see a benefit from it. Basically, it's just waiting for a signal from the DB25 to become active. You don't need it. I leave it off. Most guys leave it off. Another key thing that I want to go on right to the bottom, and you could see problem G540 unresponsive. These are just their basic troubleshooting that they have in their manual. Honestly, I don't really have a lot of troubleshooting. The Geckos work or they don't. I mean, they're one of the most bulletproof drives on the market for that reason, that they, if you run into an issue where you're in a fault mode and it will not come out of fault, honestly, there's very, very little that can be done unless you blew the drive up, okay? I've yet to see that ever happen, okay, in the sense that I've seen many guys blow up the drives. I've yet to see where it's red, you're running into a red fault-like condition all the time, and it be easily fixed if it will not come out with an e-stop, and if it will not come out with checking your terminals on your e-stop pin and your power configuration. Again, one thing to consider is on pin 10 of the breakout, which again, this is going to be a two-part video, guys. I am going to cover the physical G540 to show you that. This is going to be probably the most complete tutorial I've seen online, instead of people just showing you it in boxes and all that crap. What I'm showing to you will make you building your system a joke. If you really pay attention to it, it should be very, very straightforward. The big thing here is I want you to be educated, once again, on what you're purchasing. And with, like I said, the G540 in the situation that a possibility of it actually running into a fault condition and you not being able to get it out, there's very, very there's very little items that can make it not come out. Typically, if it will not come out with just basically checking the e-stop if it's been reset, checking the polarities on the voltage and as far as the wiring of it, if you do hook the wiring up wrong, you probably blow the drive. I've never done it myself, but I'm assuming you'll blow the drive. Again, you got to use common sense. If you're uncertain, ask. I certainly cannot emphasize that enough. I have had guys blow up their own drives, hooking motors up because they don't ask, hooking power up. I don't know if it was actually the power leads, but they were doing something with the power and blew the drive up. Again, common sense prevails 98% of the time. Big thing here, you don't know something, ask. I'm readily available most of the time on eBay. Just message me. Even if you have to wait an hour or two, it beats you going through the hassle of having to get everything replaced or whatever. That's silly. So just think about what I'm saying. Again, you can go through these. There's really not, like I said, there's very, very basic solutions here. No LEDs lit. Verify the power supply is plugged in correctly to the 12-pin terminal block. That's kind of generic. No motor holding torque. Verify your motor is connected to the G540 with the DB9, and that is wired as it says in the motor's data sheet. Again, guys, common sense. I mean, real basic. Excuse me. Problem: G540 unresponsive, red LED lit constantly. This is the most common fault and can be caused by several problems. First, double check that a jumper wire normally closed switch is present between pin 10 and pin 12 on the 12 position terminal block. Well, we know that basically that switch controls a ground. It's a ground loop. If you break the ground loop between pin 10 and pin 12 on the terminal block, the Gecko sees a fault condition, henceforth an e-stop. So there you go. That basically breaks that down. Now, that being said, what you really want to look at is if you do have an unresponsive red LED lit, that would cover about 90% of any red LED consistently lit without, without there being a more critical issue inside the drive. The big thing here is you being able to analyze what's the next step if it is consistently lit and you've already checked it, in the sense that, okay, I've already popped the e-stop, I've checked the terminal, pin 10 and pin 12, everything is hooked correctly. Then it says next, turn the charge pump switch to the off position. Once again, very basic. You want to make sure your charge pump is set to off. I ship all my drives with it in the off position. In the event you get one that is not in the off position, if something happens, I can forget, but 98% of the time they're off. Turn it off, you should get a green light immediately. If the green LED comes on, then there is a problem with your CNC program not putting out a charge pump signal on pin 16. If that does not work, check the motor for holding torque. If you do not have holding torque, move to the next selection. Again, more or less what you're looking at here is we're going through the same process of eliminating very basic tactics. You already know in this instance that if the motor doesn't have holding torque, then really something else is wrong. I mean, if it's a red LED consistently, there's got to be something else wrong. You're certainly not going to have holding torque if you're in a fault mode. The Gecko doesn't put a signal out, so therefore you're not going to have any holding torque. If the unit will not come out of a red fault condition after you checking the charge pump, after you checking your e-stop, okay, pin 10 and pin 12, contact me and we'll talk about it. Or you can contact Gecko, because odds are you're probably going to send the drive back. 98% of the time, when that system will not come out of a red fault condition, when those three scenarios have been checked, and mainly it's just pin 10 and pin 12 in the sense of the switch. Now, I have had some bad e-stops, so one thing to check is your e-stop switch. You can also put a jumper there. You can actually wire in a jumper from pin 10 to pin 12, just connecting the loop for the ground, and that should give you a green go signal. If you don't get the green go signal with that as an alternative to the e-stop, then you know you're going to have to contact Gecko or myself, and they'll replace the drive. At that point, then you should not, and I cannot state this enough, I see this done online all the time. I do not understand the thinking behind this. If you're purchasing a drive with a warranty, and it's covered under warranty, you are not the warrantier. Gecko is. Do not open the drive. Do not try to, assess what's wrong with the drive, and not for a competency thing, not for you saying, oh, I don't think you know what you're doing. Why? Why would you put yourself in a position where manipulating anything in that drive could leave you liable? You're better off just returning it to Gecko, let the professionals handle it, and they'll replace your drive. Gecko is excellent about it. That's why I sell them, and it's a very quick process. Again, it's kind of daunting in the fact that, it's a bummer. It happens, but it's be more of a bummer if you ate the profit of what you just actually spent on it. I mean, if you're putting out that kind of money on the unit, don't try to be something you're not. You didn't manufacture it. There's no need to open that drive up ever. If you're having an issue and it's covered under warranty, I'll state it once again. Mail the drive to Gecko. Contact them first, of course. Mail it to Gecko. Contact me first. I can set up we can go over the return process. It's very simple, and you're set. You never ever have to worry about, doing anything incorrectly to the drive, because sometimes it's minor. Sometimes you make more work by opening it up and, tinkering with things. You're better off just leaving it, contacting the pros, let the manufacturer deal with it. That's what the warranty is there for. Once again, Gecko is excellent. If by chance you do something to a drive, and I've had it happen numerous times with clients of mine, you're most likely going to be covered. I've yet to see literally anybody not get the drive either repaired or replaced. They will always service whatever they sell. So that being said, if any of these problems come up, you are still covered. And once again, if it cannot be fixed, it will be replaced based on Gecko. Again, the 1-year warranty is amazing with the G540. The next thing, and this I cannot specify enough. Again, you've got here problem inputs or outputs not working. I'm not really going to go into that because it's just covering, again, using a parallel port, EPP mode, and all that. If you want to read this manual thoroughly, I do recommend it. But again, I'm just covering over the topics you really should pay attention to. Problem: G540 gets hot. Guys, I have a video explaining cooling a CNC. The G540 does get hot. We're talking about 158 degrees comfortably. Okay, that's not warm, guys. That's hot. Okay, it says comfortably heat sinking is mandatory if the temperature gets above that range. Well, we know if you're putting this system inside an enclosure, and I've covered this many times. I'm one of the only guys that covers the cooling of the drive because I understand what we're dealing with here. I'm telling you now, if you put it in an enclosure and you don't have a good cooling with heatsink and fan, you risk, I didn't say you will, you risk damaging the drive due to heat. Why take the risk? Do it right. Don't half-ass it. Take your time. Build the system like you want it to be a pro system. Build it with respect. Build it with pride. And I promise you, you will have a system that you'll be very impressed with and will work for years. The big thing here is don't cut corners and take your time. And this is one of them details that bites people probably more than they think. It's one of them things, I don't need that. Other guys aren't doing it, so I don't need to do it. Okay. A lot of other guys don't do. A lot of people don't wear seatbelts, don't mean it's safe. Use common sense. Think before you leap, so to speak. And I'm telling you, it makes sense. It's in the manual, and this is directly from their manual. And if you're figuring 158 degrees is comfortable, plus you're going to have a power supply in an enclosure, which is also expelling heat, which I've covered in other videos, you already know the odds of that drive not increasing in temperature would be ridiculous, especially in a confined environment with no airflow on top of no heat sinks. You can rest assured that drive's temperature is going to go up. So be careful. Don't waste your money and think you're going to buy this and you can half-ass it to the top. I really don't recommend that. Take your time. If you don't have the money, save the money. You'll eventually have the money and you can do it right. And this way you'll look back and say, at least I did it right. And that's more important. And again, as a matter of fact, it says here, I'm going to read an excerpt from it. If the G540 is in a control cabinet or an area with limited airflow, it is required to put an intake or exhaust fan in the enclosure. Well, guys, that's common sense. What I just told you there is basically telling you, and I disagree with just putting an exhaust fan in the enclosure. It will help. It's certainly not as effective as a heatsink fan combination. So take that into consideration. Heat sinks are only, my store sells heat sinks for $18. I hope for what you're spending on your system, for the guys I'm aiming at, I hope $18 is not going to break the bank. So think about that. Do it right the first time. I'm just scrolling down now. Now you can see on the manual, you've got your 4-axis step control pinouts. Okay, you got your DB9 pinout, you got your DB25 pinout. Okay, and if you come down here, you've got your minimum. Okay, and you've got pin numbers here. And again, this is the terminal block. It's not labeled here, but this is the terminal block area for the G540. You've got 12 terminals. So again, you've got your inputs 1 through 4, your outputs 1 through 2, and that's 5 and 6. And then you've got your VFD ground, VFD output, VFD positive 10 volt. This is to hook up your VFD. Disable input e-stop is pin 10. Power supply input for the positive is on 11, and it's 18 volts to 50, and your ground is on pin 12. So right here, with just this section, between the motors and the actual the pinout from the terminal block on the G540, you have enough information to accurately hook up the system. I do recommend printing this page, guys, and keeping it as a reference, because it's very good to have when you're setting your controller up. It makes it much easier to have all this information in front of you. So if you want, I recommend it. It's very simple to do. Print it out. I also do graphics. I'm big into graphics. I do graphic design. If you guys want, I can even, I'll offer it digitally. I can actually make it into an adhesive back decal. You can then apply it to your machine. I have that in my store as well. It makes it very, very simple, especially if you're ever servicing the unit. It's without a doubt the fastest way to go in and actually not remember everything and make sure you're doing it right the first time. So just take that into consideration. Up here again, you do have your DB9 pinout, which is going to cover again current set resistor, current set resistor. So we know pin 1 and pin 5 on the DB9 get connected with the resistor. That'll be a loop. So you just attach one wire here from the resistor, and you're good there. And then again, 6, 7, 8, and 9, they're phases of your stepper motors. So phase B, and then phase B is 6. Phase B bar is 7, phase A is 8, and phase 8 bar is 9. So that tells you basically how to hook up your steppers. Guys, always get your stepper information from the manufacturer. Whoever you're buying your steppers from, make sure they include the wiring diagram correctly. It saves you a lot of time. Excuse me, I had to get a drink. You always want to make sure this information is right there available as you're assembling. I know it sounds silly, but believe me, a lot of guys forget. They're excited and they're starting to assemble things. Have all that information right there. It makes it much simpler, and you'll go through the process with the least amount of hassle as far as trying to get this information. Matter of fact, if you order them online, most people do order the steppers online, make sure they send that information immediately if possible. I include all that information when you order from me. However, some guys or some companies just list the information online. Always try to have them include it or send you an email with it as well, because it's easier to study that information in the beginning before you even get your stuff, and you'll be set. When you do get it, you'll know basically what you're dealing with. It's easier to digest that big animal. So DB25 pinout again is right here. I'm not going to get into all that. Most of this you will not be manipulating. It is good reference to have if you're hooking up accessories. And again, for the guys that are building the rocket ships, this is what you're looking at. If you want to hook up your VFD, inputs and all this for your DB25, again, that's really what you're looking at as far as the breakdown. There's your cheat sheet to go in, and you'll know where everything is going as far as the pin allocation. Again, important wiring notes. We're wrapping things up. Always verify that your DB25 cable is a straight-through cable, not a crossover. This can be done by using an ohm meter to test continuity between all pins. Guys, save yourself the headache of playing around with ohm meters and multimeters and all this other crap. Get yourself a DB25 cable that's straight through. Very simple. You know it now. I mean, it's very simple. Go online, find a straight-through cable, and you'll be set. They're pretty much readily available, and they're very cheap. I have them if you need one. I don't have them listed in the store separately. However, if you need one, you can always message me. Most of my packages all come with them because I know you're going to need it, unless you go with the UC100, which is USB, which, again, I prefer. However, budget prevailing, DB25 will work. Next one is do not allow current set resistor to touch pins 2, 3, or 4 on the DB9. This will set off a fault condition in the G540. Now, guys, this is important. Okay, I think they should have moved this all the way up under troubleshooting, because that can happen. Once again, I'll read it again. Do not allow the current set resistor to touch pins 2, 3, or 4 on the DB9 cable. This will set off a fault condition in the G540. If you're not careful when you wire your DB9s, if you're doing it manually, once again, this is why I recommend the solderless connectors. Not just because I sell them, for the simplicity factor. Truth of the matter is, if you're soldering a DB9 or if you've never seen inside a DB9 connector, it's very, very small, very tight, very small. You're not dealing with a large terminal because that connector is typically made for 28 AWG wiring. That being said, you got to be real careful you don't touch any solder or anything to do with the resistor on pin 2, 3, or 4, because you will get a fault condition. And that will appear like something's wrong. It will not come out of fault. So please make note of that. Once again, this should have been in the troubleshooting section, I think. I don't know why they put it down here, but either way, you know now. Very careful. If you're soldering those DB9s, very careful. It takes a steady hand. It's certainly not impossible to do. The big thing here is take your time. I recommend flux on any solder connection, especially with the DB9s. Some guys use heat shrink on them. I don't, because technically DB9 is not designed for heat shrink. It's simply a solder connection. You're much too tight in there to do heat shrinking properly. And the way the connector is designed, it has a clamshell which covers it, which basically means you will never make contact with those pins anyways. There's no way. If you use flux and you do it properly and use proper solder, you will have a perfect connection. The big thing there, again, 2, 3, and 4 pins can never ever touch with the resistor. So just keep that in mind. Do not use wire plugs for the main terminal block. Only put stranded wiring gauge 14 to 24 to make proper contact and not stress any terminals. Well, guys, let me tell you what. Here's the truth. I tin all my wires. I just do. It's just what I do. I've always done it. That's the proper way I've learned to solder, and it is the proper way to solder as far as I'm concerned. What they're saying there is true in one respect. If you're a guy who's constantly flexing the wire and constantly screwing into the wire, over time, you will have a problem. However, if you look at our terminal boxes, and I'm in Florida, but if you look in any electrical capacity that uses a screw terminal, we use solid core cable in all the terminal wiring junction boxes in Florida, and I can tell you right now, and this is for homes, that when you screw into a solid core wire, it stays there. You're not flexing it, you're not doing anything, it stays there, and you never have a problem. I've never had a problem with that. For guys that are constantly working on their system, constantly manipulating wires, most guys assemble it once it's working and leave it alone. Again, you do what you want. You can put the stranded wire in. I like tin wires because that's best practice as far as I'm concerned. And really, a terminal block, you're just making contact with the wire you're assembling to it, so you're set. Again, to finalize, the only required connection for G540 to run a power supply and a normally closed emergency stop. If you get a fault at any time that will not clear, you can safely disconnect all wires but these and get a green LED with the charge pump turned off. Well, once again, if you think about what I've just read there, the more stuff you have connected to this drive, the more stuff you would have to disconnect to troubleshoot if you do not get a green. So my suggestion, once again for the novices, keep it simple. You can always build your rocket ship after. Right now, have a firm understanding of what you're dealing with, especially if you're building a kit. If you're listening to this video, you're obviously wanting to learn and wanting to do it right. Then I'm assuming you really want to pay attention to things that'll bite your ass, and that'll definitely point blank bite your ass. If you have a lot of stuff connected all at once and you run into an issue, you will find yourself either disconnecting, troubleshooting for hours. I mean, guys, everything you connect, and once again, this is like the 8th time in the video I've said this, everything you connect to this drive or to your system in general, there can be a possible mistake with. So think about it with that kind of detail, that every little variable can bite you. Always dissect each thing slowly. Take your time, document everything. Keep a notepad near you as you're assembling your system. If you run into an issue, start documenting variables that you've changed. Make notes on what you've seen from that variable. Most people are not that detail oriented. And why? Because in society they have no reason to be. However, I'll tell you what, you try doing it that way, not only are you getting, a firm education in quality, because what you're going to find out real quick is, usually the problem will identify itself virtually quickly, but you're also going to find that you'll learn so much from your own mistakes. I mean, that's the big thing. A lot of guys, you know, I'll talk them through something and they really didn't learn anything. They kind of just took, you know, just given knowledge rather than saying, oh, look at what I figured out. You know, take the time, document. If you find something as a miss, take the time, write it down. What is wrong? Okay, this is the identifying problem. Then I'm going to go down that list and I'll say, okay, I'm going to change this. I did that. Checkbox. Now I'm going to change that. Okay, did that. Checkbox. You do that, you're going to find out a lot. And if you use that system correctly, especially when you go to machine, you will learn a lot, and a lot quickly, because again, you're documenting it. You're not just thinking about it, you're writing it, which incorporates a lot more brain power and a lot more. You're going to use a lot more memorization skills that way. You're going to pick up things twice as fast. Think about what I'm saying to you. Videos are good to cover the laziness aspect that we get tired of reading by ourselves and that kind of thing. That way, when you're alone and you're a mechanic for your machine as well as a designer, you're going to find that is the fastest way to identify variables. Not to mention, if you do have a problem and you go to call Gecko or you go to ask for support from me, I know everything. I can't tell you how many times I get messages from guys, oh, I built my own machine and blah, 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 and they leave out every variable. I hooked it up and I get a red light. There's no way I know. There's no way I or anyone else would know exactly what's going on with your machine. The more detail you provide, the more variables you've covered, the less work on both parts that we have to do to try to isolate what may be the issue. So please think about what I'm saying. It'll save you time. Again, time will eventually equivalent to money if you're doing it right, and it will get you ahead. So that being said, let's scroll down. Here is your basic Gecko wiring diagram. Again, I get messaged about wiring diagrams all the time. This is one right from Gecko. It's the one they include inside their the manual. So again, if you download the manual, you're going to get a copy of this. It's all inside here, and it's really basic. If you look, here's your VFD, ground input, volt positive. It's coming here again. All of this crap here, the relays, this relay power supply and crap, all of this stuff can be eliminated. Matter of fact, everything can be eliminated between 10, 11, and 12. Those are the only ones you really need. Your e-stop, your voltage into the Gecko, and pin 12, which is your ground. Okay, and that's from your power supply as well, and it also makes the ground loop for your e-stop. Other than these three, 10, 11, and 12, you do not even need all this crap. Okay, first of all, with the limit switches, how they've got them wired. Again, the Gecko's only got 4 actual ports for limit switches. They've got each limit switch set up to 1 port. You can also daisy chain the limit switches. I'm not going to get into that, to where you can have one switch basically on 1 port. Instead of occupying all 4 of your inputs, you could have one limit switch wired in conjunction with another and another and another, and just take up 1 port instead of 4. So once again, instead of taking up all 4 of these, you would just have 1. Is it required? Once again, about limit switches. Go into your software from Mach 3 or UCC&C and set up your soft limits. You do not need limit switches. You also, if you want to wire in home switches, you can use these for home switches as well. If that's what you want to do, you can do that as well. You can also set your offsets. So the big thing here is what you want to do. If you want a mechanical switch, you don't mind doing the extra wiring, guys, I'm telling you, do what you want to do. Mechanical switches, I don't trust. Again, I come from full-size manufacturing. We never would ever put, $200,000-$300,000 pieces of equipment in the realm of, even on those machines, maybe a high-end switch might be a couple $100. We would never, ever rely on a couple $100 switch on, a 6-figure machine. It just doesn't make sense. So think about that. Again, you do what you want to do. But for the guys that want to build them rocket ships, I'm telling you right now, you've got your whole exploded diagram here of how to hook everything up. If you did want to hook your VFD up, and your VFD is right here, I'll just pan up so you can see. This is your VFD drive. Here's your DC relay coils, relay power supply. Again, if you want to do all that, just imagine this for a minute. Like I was talking about, I really want you to look at this schematic because it tells you a lot. If you were to go through each one of these, each and every one of these items, and then you come over to the drive, think of all this extra work you have to do to troubleshoot. 1, 2, 3, 4. all your switches. I mean, you're looking at hours, guys, hours of hopefully getting it right. Hopefully getting it right. If that doesn't scare you enough with all this wiring and crap, if you figure out here's 3 wires, here's 2 wires, here's another 2 wires going in, then you're patching this in. I mean, come on, guys. I mean, unless you really want to deal with all that, and here's what's really funny is you're going to hook all this crap up to the Gecko. When you've got the VFD drive, you can mount the VFD drive right by your table or right by your controller if you wanted to. So you could literally just sit there and adjust the spindle speed right there. Why would you even bother? Again, I don't understand that level of thinking. I like simple. If I know my VFD is having trouble, I don't have to. I can eliminate the Gecko right away because my VFD is hooked directly to the spindle. So I can isolate the drive and troubleshoot just this drive rather than troubleshooting this drive. Then I'm coming to the Gecko. Then I'm coming over here. Then I'm hoping these are working right. This should be working right. You really don't know what to check. So looking at this diagram, if that doesn't scare you enough to think, hey, you know, simple's better, then I mean, overall, that's what you really should look at. I cannot really emphasize that enough. Keep it simple, stupid, and you will never ever run into hours of troubleshooting in that realm. You will probably run into troubleshooting, but it'll be so much easier to identify without making things overly complex, unless you're that guy. And again, I'll say it: if you're that guy who thinks, you know, I can handle it. I get guys telling me I wire houses, I've done this, I've done that. I've worked with electronics for years. Guys, look, I'm telling you, I can't tell you how many guys tell me that and then they run into issues. That's why I'm making this video. I'm making it to save you the hassle of doing it right. Do it right the first time and think. I want you to think, because this is a lot of money. It has the potential to be wonderful if you take your time and you build it correctly. And again, that's why I'm covering it this way, and I want to make you guys really understand what we're dealing with. So now that I've basically covered everything, this manual is done. On the back end of the manual, you do have a full-scale image, a CAD image, that you can use as a template to cut the Gecko slot out. If you want to install the Gecko and you're wondering how do I get all the holes and all that neat stuff, this right here is a full-size template printed at 100% through the PDF, and you will have a full-scale template to cut for the Gecko. If you don't want to do that, I also sell that in my store in a decal format, which makes it super easy. Just apply it to whatever you want, cut around it, and you're in. I mean, it's really just a question of what you want to do. And again, everything else here gives you dimensions on the back end of it, and you're set. I am going to film now the other video if you want. The other video will cover the G540 generalization as far as what you're looking at, and just give you the basic outline of what's going on with it. And you know, this manual pretty much, doing this tutorial pretty much covers everything you'll need to know with the unit itself. So if you watch this video to the end, I hope you did. I hope I didn't bore you. But if you watch the video to the end, it's going to take a lot of the hurdles out of installing this system in your chassis. So take care. Any questions, message me. Remember, again, my store, eDealers Direct. It's through eBay. Again, guys, I get questions on that too. I don't have a website. First of all, the traffic driving to a website, this is a niche field. It'd be too much to actually pay for the traffic. On top of the fact, you guys are protected. I mean, you're talking one of the highest ranking websites as far as any type of e-commerce. eBay is way up there. You guys have amazing buyer protection, and I'm proud of that, you know, and I'm proud of being able to offer you guys warranties in the States and, you know, servicing this stuff in the States. So again, if you have any questions, message me, eDealers Direct. I appreciate your time. Take care, and stay tuned for my other video.